All right, so we are just going to walk through the derivation of a few of our equations that we aren't necessarily going to graph or do a lab to find them, but I'm just going to show you where some of them come from. So, for example, defining our constant velocity or average velocity, which we have talked about a little bit. We're going to start with our new position versus time equation with acceleration. But obviously, since this is constant velocity, our acceleration is zero, right? We're staying the same. We're not speeding up or slowing down. So when you plug in 0 for a, this whole term becomes 0 and goes away. Now we're left with our x equals vt plus x naught, which we're kind of familiar with. Notice, for one, how you can get this equation from this one with the acceleration. Now I'm just going to subtract our initial position from both sides so that I'm left with final position minus initial position, which is just our delta x, right? Delta x equals x minus x naught. That's just our change in position, which leads us to this step. My final step I'm going to take is I'm going to divide by delta t on both sides. So I end up with v average equals delta x or delta t, which is kind of what we have been using so far. To do our constant acceleration or average acceleration, we will start with our velocity versus time, or our velocity versus time equation. And we will do that same step. We'll subtract our initial velocity from both sides, which will lead us to our v minus v naught equals a times delta t. Then we will go ahead and substitute delta v for v minus v naught. Then we just divide by delta t, and that leaves us with our average acceleration equals change in velocity over change in time. So these are our more simple derivations. The next one we have is going to get a little crazy.